Piston, connecting rod, and crankshaft. How the force moves. Imagine combustion has just taken place inside the engine. The burning gases create a very high pressure. That pressure pushes the piston downwards. This downward movement is the power stroke, but the piston cannot turn the wheel directly. The piston only moves up and down. So how does this straight line movement becomes rotation? That is where the connecting rod and the crankshaft comes in. As the piston moves downward, it pushes on the gudgeon pin, also called the wrist pin. The gudgeon pin transfers this force into the small end of the connecting rod. The connecting rod carries the force down to its big end, which is connected to the crankpin of the crankshaft. Now here is the important part. The connecting rod is not perfectly vertical. The crankshaft, as it rotates, the connecting rod changes its angle. So when the piston pushes the connecting rod downwards, the connecting rod applies the force to the crankpin. Because the crankpin is offset from the crankshaft center, this force causes the crankshaft to rotate. This is how the engine converts reciprocating movement into rotational movement. And that rotating crankshaft is what eventually provides the mechanical power used to drive the vehicle. But what exactly is happening to the piston? The piston is essentially a pressure-tight plunger moving inside the cylinder. During the combustion process, the piston crown receives the pressure from the burning gases. That force travels down the piston to the gudgeon pin bosses, through the gudgeon pin and into the connecting rod. At the same time, because the connecting rod is at an angle, it creates sideways force on the piston. This is called side thrust. The piston skirt carries this side thrust against the cylinder wall. So the piston is doing much more than simply moving up and down. It is receiving combustion pressure, transferring force to the connecting rod, dealing with side thrust, and operating under extreme high temperature. Now look at the connecting rod. The connecting rod, or what we call the con rod, is the link between the piston and the crankshaft. Its small end connects to the piston through the gudgeon pin. Its big end connects to the crankshaft's crankpin. The shank of the connecting rod must withstand both compressive and tensile stress. At these high engine speeds, the piston has to stop and change direction at TDC and BDC. TDC meaning top dead center and BDC meaning bottom dead center. This creates significant inertia forces on the connecting rod. This is why the connecting rod is designed for strength without unnecessary weight. Many connecting rods use a H-section shank, which gives good resistance to buckling while keeping the component relatively light. At the big end, you will normally find a big end bearing. The bearing provides the proper surface between the connecting rod and the crankpin. The engine lubricates this bearing, allowing the crankshaft and the connecting rod to move smoothly under heavy loads. Now let's come back to the piston. The piston has a very difficult job. The piston crown is directly exposed to the hot combustion gases. It absorbs a large amount of heat and must transfer that heat to prevent excessive temperature. The piston also needs a small piston to cylinder clearance so that it can move freely. But this creates another problem. That clearance can allow combustion gases to escape past the piston. It can also allow engine oil to enter the combustion chamber. This is where piston links become critical. Now let's go to the piston links. The piston links sit inside grooves in the piston in an area called the ring belt. The compression links help seal the combustion chamber. Their job is to prevent combustion gases from escaping between the piston and the cylinder wall. They also help transfer heat from the piston to the cylinder wall. Then we have the oil control ring, also called the scraper ring. Its job is different. It's to control the amount of engine oil left in the cylinder wall. The cylinder needs an oil film for lubrication, but excessive oil must not enter combustion chamber. The oil control ring scrapes away the excess oil while leaving enough lubrication on the cylinder wall. If too much oil enters the combustion chamber, it can burn, producing carbon deposits, smoke, and increased emissions. And finally, let's go to the gudgeon pin. The gudgeon pin connects the piston and the connecting rod. It transfers the combustion load from the piston into the connecting rod. There are two main arrangements: semi-floating and fully floating gudgeon pins. A fully floating gudgeon pin can rotate in both piston and connecting rod and is normally held in position by circlips. Those small circlips are important because they prevent the gudgeon pin from moving sideways and contacting the cylinder wall. Now, so follow the force one more time. The combustion gases push the piston down. The piston pushes the gudgeon pin. The gudgeon pin transfers the force to the connecting rod. The connecting rod pushes on the crank pin. The crank pin causes the crankshaft to rotate, and the crankshaft rotational movement is what the rest of the drivetrain can use to move the vehicle. Meanwhile, the compression rings control combustion pressure, the oil control ring controls the oil film, the piston skirt handles side thrust. The bearing provides controlled movement and lubrication. And all these components have to work together every time the engine completes its cycle. That is the basic mechanical chain: combustion to piston to gudgeon pin to connecting rod to crank pin to crankshaft to rotational power. Thank you. Kindly make sure you subscribe to this account so that you can find more on this.